Hey, and welcome to another video. So in this video I'm going to make a 6x6 LED matrix, and of course you can't power all 36 LEDs using a microcontroller because it only has 13 digital outputs. So I put always 6 LEDs in parallel, which is one column, and then I will pulse the 6 columns that only one column is active at one time, and I will iterate through the columns with a counter IC. So here you see the pulsed LEDs, and they are always active 6 of a full duty cycle, and in the other 5 the other columns are active. And with the eye the flickering is not visible. So here I added a counter IC, and it usually counts to 10, like I have to tap to 10 here. And it has 16 outputs, of which 2 are plus and minus, and 1 is the reset and 1 is the trigger. So if you push a higher voltage to the trigger pin, it will count 1 further, as it does here. And I added the connection between pin 6 and the master reset, so it counts only to 6. And then I added a bipolar transistor because I power the LEDs from the digital outputs of the microcontroller, and I will only connect them to ground with the IC. So the LEDs get their power from the controller, and they are grounded by a transistor, and every column has its own ground connection, and which column is connected to ground and therefore allows the LED to emit light is determined by the counter state, which is of course determined by the Arduino. So here I'm going to make a template for the LEDs, and it has 36 holes in it, and it makes soldering much more easier. Now the LEDs are added, and I add them all in the same direction, with the cathode pointing to the right and the anode pointing to the left. And once this is done, we can flip over the legs and solder all the cathodes together in rows, and the same with the anodes, and you have to make sure that you don't short them out. The whole setup can actually be used for the LED cube, and I'm going to make one, but I will not make this on such a cheap circuit board. I will create a print circuit board schematic, and then I will create a print circuit board with 6 timer ICs for a 6x6x6 cube, and they are not timer ICs, they are counter ICs. I'm sorry for that. And it's actually the most simple design I found out yet, because you only need a transistor and a counter IC, and these counter ICs are pretty much the simplest ICs to use because they only need a supply voltage and a trigger voltage, which can come from a switch, for example, to count through their outputs. So the maximum size of a matrix possible with these ICs would be 10, because they have 10 outputs. Of course you can add them together, but it would require a lot of them. But they are actually very cheap, so one is 24 cents and a transistor is 4 cents, so the whole matrix was about 1 or 2 euros. So it's really not expensive to do this, and I finished the whole thing in about an hour. So once you've soldered everything together, you have a matrix like this with these 6 cathodes all pointing to ground, and I think they are the cathodes. No, cathodes are plus. I'm sorry, that they're the anodes that are going to ground, and they will be stuck into this circuit board, and the anodes will be connected to the Arduino. I won't show the process of soldering now because it's pretty boring. I'll just show the final display or matrix, and you see you can write letters on it, and it's pretty easy to control. In the right back you see the IC, and in the front the Arduino, and below you see these 6 transistors. And I think it's pretty impressive because with the eye you can't see any flickering, and it's nice and bright, and it is actually a Q prototype. And if you use a lens like this, you can also use this as projector and project the matrix to your wall like this. So thank you for watching, hope you enjoyed, and see you on the next video.